Okay, question 3. The graph shows how demand for electricity in the UK changes during one 24-hour period. So you can see that you've got the demand in kilowatt hours here. It starts off relatively low, it increases between 4 o'clock and 8 o'clock. It stays pretty steady between 8 o'clock and 4 o'clock in the afternoon. Then there's this spike up between 4 o'clock and 8 o'clock, and then back down to its nighttime level, where it starts off there. The table gives the startup times for two types of power stations. So gas is a few minutes, it takes just a few minutes to get it started from nothing, and nuclear several days. So how would these two types of power station be used to meet the demand for electricity during this 24-hour period? They're looking for 3 marks there. Well, there's a few different things you could say. You could mention that they would accept marks for just mentioning that gas can be switched on and off quickly, but nuclear can't. Well, how is that relevant? Well, you could say that the gas then could be used to meet surges in demand. The gas could be, say, turned on there to increase for that, or even turned on there to increase for that. You could mention that the gas can contribute or meet the base load, which is just how much you have to use sort of all the time, or you could say that nuclear provides the base load. So you could have nuclear provides the base load, gas can contribute to that, but can be turned on to meet increases in demand, whereas nuclear can't meet the increases in demand. So any 3 from nuclear provides the base load, or the nuclear generates all the time, or the gas can contribute to the base load, or the gas can be used to meet surges in demand, and you get a credit for just saying that the gas can be turned on or off quickly. So in this question, you obviously have to answer it in full prose with good spelling and punctuation. So you have to think out your answer first before writing it down. So a farmer plans to generate all electricity needed in their farm using either biogas generator or a small wind turbine. Biogas generator burns methane. This would come from rotting animal waste in the farm, but it produces carbon dioxide. It would cost £18,000 to buy and install. The wind turbine is more expensive, £25,000 to buy and install. The average power output from the wind turbine would be the same. So evaluate the advantages and disadvantages of the two methods generating electricity, and conclude with a reason which system would be the better for the farmer to buy and install. So they're looking for you to weigh up advantages and disadvantages of each, compare them, and then make a choice. So it's not necessarily a right answer as to which is the right one. You have to justify your answer. To get 5 or 6 marks, you need to have a clear, detailed comparison. There must be a clear conclusion, which is best, with at least one reason comparing the two for your answer. For 3 or 4 marks, you'd have maybe some advantages, some disadvantages, or you'd look at one in particular. But so what they're looking for is, well, you can say with the biogas, it's renewable, so it's got a free energy resource, but that's the same for the wind turbine. You can say it is reliable, the biogas is reliable, it doesn't rely on the weather, whereas the wind does rely on the weather. You could say it uses up the waste animal products. You could say it's cheaper to buy and install, it's going to be a shorter payback time, but it adds carbon dioxide to the atmosphere, and therefore contributes to the greenhouse effect. But you can also say there's no transport cost for fuels. For the wind turbine, you could say, well, it does depend on the weather, so there'll be some times when it's maybe not producing enough electricity. It's got a longer payback time, it's more expensive, but it doesn't produce any carbon dioxide. So you'd have to pick which one you like the best. You could say just choose the biogas, whereas both of them are renewable, both of them have free energy resources. Biogas is cheaper, it would take less time to pay off, and is reliable, it would work all the time, whereas wind power obviously depends on the wind. Something along those lines. Question 4. A student investigates the refraction of light as it passes into and out of a clear plastic block, and there's the apparatus used. And you can see there that light goes in, bends down towards the normal inside the glass block, and then moves away again. And if you look carefully, this ray and this ray are pretty much parallel to one another. So here we've got the same apparatus, but just arranged in a slightly different way. So up here you've got the ray box over on the right hand side, whereas down here you've got on the left hand side, was here you've got it on the right hand side. But you're going to have to do the same thing. You're going to have to do the ruler. What did it do when it went in this way? Well, it bent down towards the normal. And you should make sure that there's no gap there. And then what happened there? Down here, it bent away from the normal. And it should end up parallel to this first ray. So it should be something like that. So if you had traced that down, this ray and this ray should be parallel. So you get 1 mark for bending this ray down, so it's closer to the normal than up here, and then the second mark for refracting it out again, so it's parallel. Part B. The student measures the angle of refraction for different angles of incidence entering the plastic block. What 2 conclusions can be made about the relationship between the angle of incidence and the angle of refraction from graph 1? Well, as you can see, that as the angle of incidence increases, the angle of refraction also increases. So that's 1. As angle of incidence increases, so does angle of refraction. But if you look at the actual numbers, angle of incidence is 10, that's about 7, there's 40, that's about 25. The angle of refraction is always smaller than the angle of incidence. So those are the 2 things. Angle of refraction is always less than angle of incidence. The angle of refraction increases as the angle of refraction increases. Here the experiment is repeated, but as well as having your air into plastic, you've got air into water. So it's a similar line, but slightly different. How does the refraction of light passing from air into water compare to the refraction of light passing air into plastic? Well, for the same angle of incidence, let's pick 40 there, the angle of refraction in plastic is smaller than the angle of refraction in water. That's what they're looking for. So the angle of refraction in plastic is less than the angle of refraction in water. And question C. In some countries, people are too poor to pay for electricity. Some people living in small houses with no natural light are using bottles filled with water instead of light bulbs. Bottles are fitted into small holes in the roof of the house, so sunlight refracts into it as it passes into and out of the bottle, causing light to spread into the room. And the simple device gives me the same amount of light as a 50-watt light bulb. So basically, you put the light hitting the bottles, and then it's refracted out into the room, so it can light up the room inside. Suggest one way this simple device can help improve the lives of people using it. Well, they're looking for any sensible suggestion that's to do with being able to see better inside. So you'll be able to see to do some work, or able to cook inside, or read inside, something like that. It's not enough just to say it lights up the room. That's not enough. You have to say, well, what's the benefit of lighting up the room? And it's not enough to say, well, it means they have to pay for electricity, because they weren't able to pay for it in the first case. So that's not the benefit. The increasing use of energy resources to generate electricity within deprived countries has an ethical implication. Suggest one ethical implication. Well, so you have to look at energy resources and how they affect people, how they affect society, really. So something like, some comment about if you want to talk about the environment, well, you can't just say that using energy resources can damage the environment. You'd have to say that damage to the environment affects all people, or will affect people in the future in terms of energy resources left over. Or you could mention that some places have unequal access to energy. So some people we've got lots of energy. People in these other poor countries might have not have access to energy. So something along those lines.